Once it blasts off into space, this 8-ton satellite will orbit the Earth, beaming back data on changes in land and ocean levels, temperature change, and weather patterns. Scientists say the combination of instruments on board will help answer key questions on ozone depletion and climate change. It will allow us to study different aspects of the Earth's environment in more depth than ever before, from the stratosphere through to the atmosphere of the Earth's surface. This technology will allow us to look at the oceans, ice, and even down to the deep geology of the Earth below the ocean. The British government has invested £300 million in this European Space Agency monitoring project, and 11 British companies have built on-board instruments. These include a high-resolution radar system called ASAR that could help provide early warning of severe weather and earthquakes. Previous imaging systems from space have had problems with clouds, which make it impossible to see. However, ASAR has the ability to see right through clouds and provide information about and map very small deformations in the Earth's surface. This may make it possible to predict earthquakes and volcanic events. This data should convince any remaining doubters about the need to protect our environment. One of the advantages of space technology is its ability to expand our knowledge and understanding of the world around us. Ozone is an invisible upper atmospheric gas that protects all forms of life on Earth from most of the sun's damaging radiation. Radiation that can cause skin cancer, eye damage, and suppression of the immune system. The harvesting of fish and plant life are also affected. A vast amount of aquatic life has its beginnings in the oceans around Antarctica. False colour imagery of the South Pole from NASA's Nimbus 7 satellite provides scientists with a roadmap of daily changes in the ozone. By tracking this imagery, they have discovered a trend each spring over Antarctica. A hole in the ozone develops at this time, and it is beginning larger every year. To date, as much as 50 to 60% of the ozone in this area has been lost. These discoveries prompted a coordinated series of Antarctic ozone experiments. Scientists used ground-based instruments and launched balloon-borne payloads to sample air chemistry at McMurdo Station in Antarctica. At the same time, NASA's DC-8 flying laboratory studied the lower atmosphere, making long missions into the area of ozone depletion. NASA's high-flying ER-2 plane, carrying a single pilot and a handful of sampling instruments, flew directly into a layer of atmosphere where the ozone was depleted. A number of activities contributing to ozone loss had been pinpointed by the scientific and policy community. No longer do aerosol cans contain chlorofluorocarbons or CFCs, but these harmful gases still get into the atmosphere because they are used as refrigerants, fire retardants, foam-blowing agents, and solvents. As long as this persists, ozone will continue to be lost. Initial findings from the ozone depletion expedition verified that there is a complex interplay between CFCs, chlorine-containing gases, and the meteorology in certain parts of the world. Ice crystals in the upper atmosphere convert the gases into a byproduct that destroys ozone. These ice crystals usually only form in the atmosphere of the South Pole because it gets so cold. This may explain why other parts of the world aren't dramatically affected by the depletion. Scientists still do not understand all the mechanisms of change, but thanks to the work of so many, we now have a much greater understanding of ozone loss and its threat to the world environment. And thanks to space technology, a new generation of atmospheric satellites has started to probe the problem even further. Launched in 1972, NASA's Pioneer 10 spacecraft accomplished many firsts over the course of its space odyssey. One was a successful passage through the rocky asteroid belt, a feat which greatly alleviated the fears of scientists concerned about damage to far-travelling spacecraft. Having safely journeyed the 2.5 million miles to Jupiter, Pioneer 10 transmitted valuable scientific information back to Earth. Information shedding new light on the composition and evolution of Jupiter and its moons. On June 13, 1983, Pioneer 10 began a journey beyond all the known planets to become the first man-made object to leave the solar system. As NASA's Deep Space Network continued to track the spacecraft out to about 5 billion miles, researchers tried to learn as much as they could about the boundary between the Sun's atmosphere and true interstellar space. Pioneer 10, a man-made object which has, from a new vantage point, in Walter Whitman's words, looked up from a great silence at the stars. Being able to determine the condition of components like the shuttle's main engines is critical, and that's the primary goal for this NASA-sponsored research effort at the University of Cincinnati. A team of faculty members and graduate students is developing a series of microsensors to indicate the health of spacefaring vehicles. Almost everything visible here is just packaging used in testing. The sensor itself is just a tiny speck in the center. Viewing one of these sensors under a microscope reveals their sophistication. Advanced micro-machine techniques make it possible to include valves, heaters, or even motors in a device with a diameter less than that of a human hair. The goal is to embed these tiny flow sensors into the walls of critical shuttle engines and system components to ensure they're functioning properly. The sensors are so small that even if one came loose, it would have a negligible effect on engine performance. Researchers are also working on vibration and crack detection centers for other parts of the shuttle, which could point out existing defects or indicate fatigue in high-stress areas where problems might occur. There are a number of potential spin-off applications from microsensors like these, and researchers at the University of Cincinnati Medical Center are already exploring their use in the care of premature infants. A significant number of premature infants suffer respiratory disorder, and many must be connected to a ventilator around the clock. But setting the ventilator remains a relatively imprecise science, and improper oxygen levels can contribute to more severe problems, including damage to the brain. The medical researchers are studying the possibility of putting a microsensor inside the plastic tube inserted in a baby's trachea. Advanced microsensors enhancing the health of spacefaring vehicles and those who may one day fly them. Extended stays on board the International Space Station allow us to study human adaptation to space for short durations. One of the problems astronauts experienced during shuttle flights was space adaptation syndrome. On Earth, it's called motion sickness. Many of us suffer from it, but in orbit, time must be used as efficiently as possible. Considerable efforts are being made in the hope of finding a treatment and eventually a cure for this condition. NASA is doing extensive research, and microgravity provides the perfect and only reliable testbed because the vestibular system's reliance on gravity for stimulation biases all ground-based results. Space removes that bias. These and many other investigations will help to answer fundamental questions about humans in space. How can we live healthy, happy, productive lives in microgravity and return to Earth safely and in good health? While on the moon during their Apollo 16 mission, astronauts Duke and Young spent some of their time driving around. Their first traverse took them about 1 kilometre west of the landing site. They made 2 stops to collect samples and conduct some experiments. As Mission Control watched on, Young used a portable instrument to measure the local magnetic field. He would later record the most intense magnetic field ever discovered on the moon, far higher than scientists ever suspected. The astronauts then inspected a huge crater site, while NASA's geologists at Mission Control directed them towards grab samples, the moon rocks they wanted to be brought back to Earth.
As you come around there, there's a rock in the near field on this rim that has some white on the top of it. We'd like you to pick it up with the grab sample. This one right here? That's it.
There would be one more stop before they got back to the lunar module. With astronaut Duke acting as action photographer and Young as driver, they put the lunar rover through a full test.
You are really bouncing. Is he on the ground at all? That's 10 kilometers.
At 10 kilometers an hour, Young could hardly keep 3 wheels on the ground at any one time, but never had so much fun trying. He later compared the experience to skidding across loosely packed snow back home. But it really has to go down as one of the most unusual test drives in human history. The following day, their third, Young and Duke headed north about 5 kilometers to North Ray Crater, the largest lunar crater to be explored and sampled by man. The ride in the rover was the most comfortable of the entire journey, as the lunar surface was much smoother here than on the previous trip to South Ray. No speed restrictions here. Then on the trip back, they'd realised that the rear mudguard had come off the rover, kicking up a shower of lunar dirt at them. The next day, with the lunar surface temperature reaching 135 degrees in the sun, the astronauts travelled a little over 4 kilometres south to climb their rover up the steep side of Stone Mountain. Young parked the rover and moved out to join Duke. All things on Earth, living and inert, are formed from the elements forged in some distant and unknown star. On Earth, atoms join together in definite numbers and patterns, compose the organic molecules which form living cells. Since the discovery of complex molecules in the chilled vacuum of interstellar space, there is reason to believe that among the countless galaxies in the universe, there are stars orbited by planets favourable for the evolution of intelligent life. Is space travel to these planets possible? Time and distance may be insurmountable barriers. The spacecraft Pioneer, now speeding toward the outer planets and beyond, travelling at 35,000 miles per hour, would take almost 80,000 years to reach the nearest star, Alpha Centauri. A spacecraft travelling 2,500 times faster than Pioneer, at 10% the speed of light, would require so great an expenditure of energy that until new sources have been tapped, it must remain an invention of science fiction. A more practical strategy in the search for extraterrestrial life is to tune in on radio signals beamed perhaps by creatures on the planet on some distant star. Someday, an array of telescopes, earthbound or lifted to the far side of the moon, may hear faint but unmistakably meaningful sounds amidst the din of cosmic radio chatter. That moment will signal a change in the human condition that we cannot foresee or imagine. For man, wrote H.G. Wells, there is no rest and no ending. He must go on, conquest beyond conquest, and when he has conquered all the deeps of space and all the mysteries of time, still he will be at the beginning. An information centre has opened to educate people about the risks from comets, asteroids and other space debris crashing into Earth. The centre is housed at Britain's National Space Centre, a treat for children and adults alike interested in space. The threat of comets or orbiting asteroids smashing into Earth is a hot topic. When fragments of a comet hit Jupiter 8 years ago, each one produced a crater the size of Earth. The British government asks scientists to assess the risks to Earth of such orbiting rocks up to 1 kilometre across, flying at several kilometres a second. The scientists say more research is needed into the size, speed and path of these objects. In 1986, the European Space Agency's Giotto spacecraft made history by flying close to Halley's Comet as it passed near Earth. Now scientists are considering ways to nudge harmful meteorites away from Earth. Visitors to the centre and its website will learn about the 415 potentially hazardous asteroids already discovered. Astronomers are watching one object with a 1 in 300 chance of hitting Earth. But it won't come by for 800 years, so there should be some time to do something about it. As NASA prepares for long-term space flights, keeping astronauts healthy has become a top priority. Increased focus on in-space exercise, diet and physical monitoring has led to the robotic eye doctor. This computer can quickly detect a variety of eye diseases and even some brain tumours on Earth and in space. It was developed for NASA by Dr. Wolfgang Fink while at the California Institute of Technology. Patients stare at a point on the touch-sensitive screen and outline the missing areas of a grid with their finger. The computer analyzes the results, displaying a 3D image of the patient's field of vision. It can pick up conditions like macular degeneration and glaucoma, both of which must be diagnosed immediately to prevent blindness. Researchers envision the system being used in space and commercially as early as next year. This is the Space Shuttle Challenger, and the date is January 28, 1986. Unknown to everyone at NASA, this was a flight that was never meant to be. It would have been the 25th successful shuttle flight into space. And these are the crew members of that flight. Commander Francis Scobie, Mission Specialist Judith Resnick and Ronald McNair, Pilot Michael Smith, Payload Specialist Sharon Krista McAuliffe, the first school teacher on a shuttle mission, Mission Specialist Ellison Onizuka, and Payload Specialist Gregory Jarvis. At this point, everything was proceeding exactly to plan. In this footage from the antechamber, just outside the shuttle proper, technicians assisted one crew member at a time with their personal equipment before giving them the go-ahead to enter the craft. In the top left of screen, a yellow supply tube can be seen entering the shuttle, carrying lines of oxygen and purified air.
T-minus 15 seconds. T-minus 10, 9, 8, 7, 6. We have main engine start. 4, 3, 2, 1, and liftoff. Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
Roger, roll, Challenger. Good roll program confirmed. Challenger now heading downrange. Engine's beginning throttling down now at 94%. Normal throttle for most of the flight, 104%. We'll throttle down to 65% shortly. Engines at 65%, 3 engines running normally, 3 good fuel cells, 3 good APUs. Velocity 2,257 feet per second. Altitude 4.3 nautical miles, downrange distance 3 nautical miles. Engines throttling up, 3 engines now at 104%.
Challenger, go with throttle up.
At only 59 seconds into the flight, flames began to appear on the right side solid rocket booster. By 72 seconds, at a speed of Mach 1.92 and an altitude of 46,000 feet, an external hydrogen tank ignited. Since the tragic accident, the cause has been attributed to a structural failure in the joint between the 2 lower segments of the right solid rocket motor.
Flight controllers here looking very carefully at the situation. Obviously a major malfunction.
For such a successful operation, the sight of the falling debris that was once a shuttle was ghostly and surreal. After the tragic accident, debris would periodically wash up on the beaches of Florida. One of the largest segments to do so would be a 2x4 meter rectangular section of the wing that was discovered on Cocoa Beach some 11 years after the accident. It was recovered by officials at Kennedy Space Center from about a meter of water and crusted in barnacles. And 11 British companies have built on-board instruments. These include a high-resolution radar system called ASAR that could help provide early warning of severe weather and earthquakes. Previous imaging systems from space have had problems with clouds, which make it impossible to see. However, ASAR has the ability to see right through clouds and provide information about and map very small deformations in the Earth's surface. This may make it possible to predict earthquakes and volcanic events. This data should convince any remaining doubters about the need to protect our environment. Once it blasts off into space, This 8-ton satellite will orbit the Earth, beaming back data on One of the advantages of space technology is its ability to expand our knowledge and understanding of the world around us. Ozone is an invisible upper atmospheric gas that protects all forms of life on Earth from most of the sun's damaging radiation. Radiation that can cause skin cancer, eye damage, and suppression of the immune system. The harvesting of fish and plant life are also affected. A vast amount of aquatic life has its beginnings in the oceans around Antarctica. False colour imagery of the South Pole from NASA's Nimbus 7 satellite provides scientists with a roadmap of daily changes in the ozone. By tracking this imagery, they have discovered a trend each spring over Antarctica. A hole in the ozone develops at this time, and it is beginning larger every year. To date, as much as 50 to 60% of the ozone in this area has been lost. These discoveries prompted a coordinated series of Antarctic changes in land and ocean levels, temperature change, and weather patterns. Scientists say the combination of instruments on board will help answer key questions on ozone depletion and climate change. It will allow us to study different aspects of the Earth's environment in more depth than ever before, from the stratosphere through to the atmosphere of the Earth's surface. This technology will allow us to look at the oceans, ice, and even down to the deep geology of the Earth below the ocean. The British government has invested £300 million in this European Space Agency monitoring project,